Welcome to our short journey into the fascinating world of condensed matter physics. Condensed matter physics is a branch of physics that deals with the physical properties of condensed phases of matter. Primarily, we look at solids and liquids, but there are more exotic phases like Bose-Einstein condensates, superconductors, and quantum Hall effects that pique our curiosity. At its core, condensed matter physics seeks to understand how the vast array of physical properties, such as electrical conductivity, magnetism, elasticity, and thermal properties, emerge from the interactions between a large number of atoms or molecules. For instance, why is diamond an excellent insulator while graphite, which is made from the same carbon atoms, conducts electricity? This field is rooted in quantum mechanics and statistical mechanics. Quantum mechanics allows us to describe the behaviors of electrons and atoms at the tiniest scales, while statistical mechanics helps us understand how these microscopic behaviors translate into macroscopic phenomena. One of the cornerstones of condensed matter physics is the study of crystals and their structures. The arrangement of atoms within a crystal lattice significantly affects its properties. This is where concepts like Brillouin zones and band theory come in, helping us comprehend how electrons flow through materials and why materials behave as metals, insulators, or semiconductors. Superconductivity, discovered in 1911, is another captivating topic within this domain. At very low temperatures, certain materials exhibit zero electrical resistance and expel magnetic fields, a phenomenon known as the Meissner effect. Understanding superconductivity holds key implications for creating lossless power grids and powerful superconducting magnets used in MRI machines. Let's not forget the quantum Hall effect and topological insulators, showcasing how condensed matter physics intersects with topology, giving us entirely new states of matter with promising technological applications. Finally, condensed matter physics doesn't just deepen our understanding of the physical world, it shapes the technology we use every day. Innovations in electronic devices, magnetic storage, and even quantum computing all have roots in this broad and dynamic field. Thank you for joining us on this exploration of condensed matter physics.